Struggling to backtest your coding strategies in Python? You've come to the right place. Today I'm going to teach you how to build a very minimal backtesting library, which I built out in order to test my own code trading strategies. I'll talk about how the library sort of visualizes the trades, what are the main features of the library and how it works. And not only that, I'm going to tell you how to execute all of the code in this library from scratch. As always, you can find the download link to in the description box below so that you can sort of download the code and execute it in your own time. Please like and subscribe the video if you like to see more videos about trading strategies and Python. Now, having said that, why did I build my own backtesting library? So I see the main motivation for my backtesting library was this library called backtesting.py. So I started out, if you looked at my previous videos, I started out by sort of writing down from scratch all of the backtesting code every time I would sort of test a new strategy, and then eventually I got tired of it and I tried to search for backtesting libraries. This one is used extensively by traders, a lot of traders in YouTube, and I really love how they sort of present the results here. But I wanted to build my own, which was sort of more minimalistic. It doesn't have the full-blown functions of backtesting.py, but on the other hand, I did it because of two things. The first important reason is that it allows me a lot of control over exactly what I want. So for example, I only trade long strategies and I don't trade short strategies. That's what I teach. So that's kind of like there are some very particular things that I want in my backtesting algorithms, and it sort of gives, it allows me to incorporate those things. Secondly, I like to control my visualization, and this allows me to fully control it. And finally, I think it helps me debug the library if something goes wrong with my strategies. So having said all of that, let's look at what it does and how it works. So as usual, we start with some data, which is you will find in the description box as well. If you want to download this Bitcoin data, this is I think 5-minute data for Bitcoin, and it is in a data frame which shows open, high, low, close, and sort of an index of the time, which is the lock index here, and then there are some nice sort of time representations of strings. And that's the data set that we are working with. So we take a small sort of slice of that data set, the first 1,000 values, and then we define a strategy. So we can define a large number of strategies here. In this case, we define a strategy called a random strategy, and we tell the algorithm how much cash we have in order to execute the strategy. And then we define the backtest, and the backtest function takes in the data frame, which contains the prices, the open, high, low, close, and then it contains the strategy. So given the prices and the strategy, it sort of executes the strategy when I use this run test function, and it does that by sort of iterating through each row of this data frame. And then when I ask it to show the stats, it basically gives the stats, which again, the backtesting.py library has a much more extensive stats, but here are the stats that I really care about: the number of trades, the win rate, which is, the number of winning trades divided by the total number of trades, the percentage return. An important comparison is what would have happened if I just bought and hold. And that tells you that are you doing better than buy and hold? That's something I'm always interested in. And then the total profit and the initial capital. So those are things that I care about. There are other sort of metrics that I don't care about that much. And finally, the visualization, which is really important for me. If I sort of say this is like a verbose argument. So if verbose is true, then it also tells me each of the single trades, what the buy time was, what the sell time was, price, and whether it was a profit or a loss. And finally, we see the visualization here. And the visualization basically says that this is like the buy time of the trade. This is the sell time. If the trade is a loss, we mark it with a cross. So these trades were losses, and then these trades were sort of wins. So that's what this is, really simple, really minimalistic, and that's all that it does, but it allows you to test your own strategy. And you are free to define your own strategy instead of the random strategy, which I will come to how to do that. So now let's get into the nitty-gritties of the code. So in order to define this, first let me go through some of the classes that we define, and then we'll sort of talk about how they all work together. The first is the candle. So the candle is simply, the open, high, low, close, and what is the index of the candle, which is like like the time index. Then there is the stats, which allows us to print this nice stats when we do the show stats. So we just gather all this data in a data class. And if you're not familiar with data class, it's just a way of it just makes it easier to define classes which only contains values and doesn't actually do anything, like there's no method associated with this class. So we just record the number of trades, win rate, and so on, and then we just print it in a nice way, which is what the repr function does. And then we have a class called trade, and this represents one single trade and everything that's associated with the trade itself. So what is the buy price, sell price, time index, when it was bought and sold, profit, loss, stop loss percentage. This is the take profit and the stop loss percentage in the trade. So that's how I want to define my trades. And so it helps me to sort of write down the library this way for me. So if the trade is closed or is it open, so that's an important thing. And then finally, there is there are some methods associated with it. And then maybe I can just go through them briefly. Here's just update, which says if you want to update the take profit and the stop loss values, these are essential if we use like some kind of a trailing stop loss. And then it tries to close the trade. So if we are below the stop loss, or if the current candle is higher than the take profit value, it closes the trade. Otherwise, it sort of and returns true. Otherwise, it returns false. If the trade is already closed, it returns false. And then we define a base strategy from which all other strategies derive from. And in the base strategy, we say, how do you want? So we define a buy. So when we execute buy, basically we are entering a trade, and this just is some function which allows us to sort of do that. It defines a new trade class. So this is the class for a single trade. It defines a new object of the trade class and appends it to sort of all trades list. So we have a list of all the trades in our strategy, and then when we buy, we just add a new trade class. And then finally, the most important one is run. And the run is the function that we call from our backtest. So it contains data about the current candle prices and also some other information about the candle, like an SMA or some other information. And then there is a get stats, which is used to sort of calculate all of the statistics. So this tells us like number of wins, number of trades. So if for each trade, if the trade is closed and it's on a profit, we calculate that as like a win, and we calculate the length of that. And that gets us the final stats. And so here is a strategy. So you can define your own strategy, and we'll in subsequent videos, we'll describe more sort of complicated strategies. But to start off, we defined a random strategy, which is basically what it says. It defines the run function. So as I described all my so the random strategy inherits from the base strategy. Anything that inherits from the base strategy needs to define the run function. And it defines the run function by saying that, well, for all open trades, try to close the trade. And then generate a random number. If the random number is 1, then buy. That's basically the strategy. So randomly enter a trade, and if you have a take profit or a stop loss reach, then sort of close the trade. And yeah, this is some helper function to plot. And then finally, this is the backtest class, which you saw in the main execution. So backtest is where I used the data frame and the strategy. So in the backtest function, there is the run test, which is the main sort of function in this class, which is run. And basically, it just goes through every row of the data frame. For each row, it constructs the current candle with the open, high, low, close prices. And then it calls the run function of the strategy, which is the function that every sort of strategy should should implement. And in the run function, you have to say what is some condition which you use to buy. In this case, it is random variable equal to 1. And then what is a condition for closing, which is, I've reached my take profit and stop loss values. So for every iteration of this loop, I execute the run strategy. And then if there are trades that are sort of still lying open, I force them to close. Basically like sell them at the market price. I don't care at a profit or a loss. And then finally the show stats will sort of print the, it will calculate the stats for the strategy and print out the final stats. And this is the visualization where we construct a data frame for the buy, sell DF. And then we do our candlestick chart. And then after that, we sort of plot the buy time and the buy price and the sell time and the sell price. And finally, if the sell price is less than the buy price, if it's a loss, we plot like a cross sign. And so that is what, sorry. And that's what we observe. So we run the random strategy here. We observe for some reason it has a good win rate, but that doesn't mean anything. Maybe it's just pure luck. And then we've had like 15 trades, and we can see sort of all the 15 trades here. And then you can see like these are sort of just randomly, trades which are completely randomly taken. Some of them are lose, some of them win, especially when the sort of stock is going down, the random trades seem to lose. So that was an overview of my backtesting library. I'll be using this backtesting library to run a lot of more complicated strategies in the future. So look out for those videos, and please like and subscribe if you like the content that you see here. Thank you.